Hello, good evening to everyone. Myself, Muhammad Tajuddin. Today, I am going to explain a small topic, steady state of linear systems, written by M.V. Volkenstein in his book BIOPHYSICS. So, in thermodynamics, we know that there are three systems, namely open, closed and isolated systems. So in this video I am going to talk about open system. So open system may be in the steady state or in the linear state. First of all, I discuss about steady state. Open systems are in the steady state, which is the non-equilibrium state. Therefore, the change of entropy is described by the flow of matter into the system to the outward of the system. So this entropy change is, the net entropy change is zero, because the flow which goes outside of the system is compensated by the flow which comes inward to the system. For the stationary open system or in the equilibrium state, it differs by many specific features, such as the stationary state of open system achieved by if system constraints to be a fixed constant value of forces, which means in the stationary system there is no change in the value of the forces, that should be the constant. So in the stationary system the entropy doesn't attain maximum. For example, suppose a system exchanges the matter and energy with the environment. So in the open system, they exchange both also, energy and matter also. So if the flux of energy, which means heat, is denoted by Jt and influx or outflux of the mass is denoted by Jt, therefore entropy is equal to Jt xt plus Jm xm, where xt is the force at a temperature T and xm is the force at mass m. Thus stationary state close to equilibrium, entropy is minimum. This is called Prigogine theorem. So Prigogine theorem states that in the open system which attains stationary state, which is close to equilibrium, the entropy is minimum. So in equilibrium state there will be a movement where net movement is equal to 0, but there will be a movement. So the kinetics are derivative of Na is equal to derivative with respect to the temperature e to e into x to the power n into a minus v1. So in stationary state the content of all reactant is constant in flow through the system. So the stationary state doesn't mean the movement is 0, the net movement is 0, but there will be a movement. So in this figure, the 9.1, which says that the velocity is determined by the tap aperture, because the velocity of water is not going outside, or velocity only coming by the tap, so it is determined by it. By what about the figure 9.2? There is two beakers which connect with the tap, so the velocity is determined the first beaker, first tap, and for the velocity of water in the second beaker determined by the tap of the second. So this figure 9.3, it's a diagram illustrating the behavior of steady state linear system. So this diagram is often used in the contraction theory and stability analysis of the linear system. So totally the open system may be in the steady state or in the stationary state. There is a movement and there is change in entropy, but the net entropy change is 0 and the net equilibrium or net movement or kinetic movement is 0. That's all. Thank you.